Hello guys, in today's video we are going to discuss the solution of the problem reverse level order traversal. So let us look at the problem statement. The problem statement says that given a binary tree of size n, find its reverse level order traversal. That is, the traversal must begin from the last level. If this is the binary tree which is given to us, then the reverse level order traversal will be 3, 2 and then 1. Similarly, if this is the binary tree which is given to us, then the reverse level order traversal is 40, 60, 20, 30 and then 10. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So here what we are going to do is we are going to perform level order traversal. And once we have performed the level order traversal, and let us say we will put this level order traversal in a list. Let us say that list is the answer list. So once we have the level order traversal in the answer list, then what we are going to do is we are going to reverse this list. So that's the general idea for this solution. There is just one caveat over level order traversal, and let us discuss that. So to understand that, let us take a binary tree. So if this is the binary tree, then the reverse level order traversal will look something like this. So this is how the reverse level order traversal will look like. Now in order to achieve to this, what we are going to do is while performing the level order traversal, instead of inserting the left element first, we will insert the right element first in the queue. So what do I mean by this is, rather than doing the level order traversal like this, which is 1, 2, 3, 4, 5, 6 and 7, what we are going to do is we are going to do the level order traversal where we are iterating on the right node first, then the left node. So the level order traversal will be something like this: 1, 3, 2, 7, 6, 5 and 4. And the reason why we are doing it in this way is because if you reverse this, then the reversed list for this list will be 7, 6, 5, 4, 3, 2 and 1. But this is not we want it to be, right? This is not the correct reverse level order traversal. Rather than that, if we reverse this list, which is 4, 5, 6 and 7, 2 and 3 and then 1, this is what we want to obtain. And that is the reason why we are pushing the right element first or the right node first rather than the left node. So now let us discuss the level order traversal, and then we will discuss how we will be able to reverse this list. So let us first discuss the level order traversal. So let us say this is the binary tree which we have, and as we know in the level order traversal we need a queue. So let us say this is the queue which we have, and initially what we are going to do is we are going to insert root on the queue. So right now the queue contains this. Now we will iterate on queue while queue is not empty. And the first thing which we are going to do is we are going to dequeue the queue. So once we dequeue the queue, the element which will obtain is 1. And what we are going to do is this will be our answer list. And this dequeued element is something which we are going to insert in our answer list. So the dequeued element is 1 and that will be inserted. And remember over here, since we have dequeued the element, so 1 is gone from queue. After dequeuing the element, so this is essentially how we have obtained this is root equals to queue dot pop left. And this pop left is essentially we are dequeuing from the queue. And once we have dequeued it, then we are going to insert the left and right child on the queue. So as we have discussed above, first we would like to iterate on the right child. So we will check whether the right child exists or not. If the right child exists, then we are going to put this element on the queue. So let us do that. So queue dot append root right. And similarly, if root dot left exists, then we are going to put that element on the queue. And we will do this till the queue is not empty. So let us first append the right and left. So the right element is 3 and the left element is 2. Again, we are going to dequeue from the queue. So this time the value will be 3 and 3 is something which we are going to insert in the answer list. Then we are going to check whether the left and right child exist for the popped node or not. Over here it exists, and remember we have to insert the right one first, so 7 will come first and then the 6. After doing that, we are going to pop the next element from the queue, which is 2, and 2 is something which will be inserted over here. Again, we are going to check whether left and right child of queue of 2 exist or not. Over here it exists, and then 5 and 4 will be inserted over here. Similarly, we are going to pop the next node, which is 7, and 7 will be inserted over here. Since there isn't exist left and right child of 7, that is why we are not going to insert anything on the queue. Proceeding forward, 6, 5 and 4 will be popped in this fashion, and that will be inserted over here. And towards the end, we will have this answer list. Now, once we have this answer list, what we are going to do is we are going to reverse this. And the way we are going to reverse is something like swap operation. So what we are going to do is we are going to set I equals to 0 and j equals to length of answer minus 1. So I on the first element and j on the last element, and we are going to iterate while I is less than j. And then we are going to swap the elements. So temp equals to ai or answer I equals to answer j, and answer j equals to temp. And once we have done this, we need to increase our pointer. So I will be increased by 1 and j will be decreased by 1. And in this way, we will be able to reverse the answer list, and then we will go ahead and return our answer. So that's the discussion of the solution, folks. Now let us see how we can implement this in Python. Since we are going to use queue, so let us import queue from our collections. So from collections, import dq. Now let us fill our reverse level order traversal. So the first thing which we need is an answer list. So let us have an empty answer list with us. And then let us check if the tree is an empty tree. If the tree is an empty tree, then we are going to return answer. Otherwise, let us do the level order traversal. So in the level order traversal, we will put root on the queue. So let us say there is a queue, and let's create an object of dq, and let us put root on the queue. And then we are going to iterate on queue while queue is not empty. So length of queue exist or length of queue not equals to 0, we are going to iterate. And then the first thing which we are going to do is dq from the queue. So let us do that. So queue dot pop left. And this way we dq from a queue, and then this information needs to be appended to the answer list. So let us append this root dot data. Once we have operated on the root, then we need to check whether the right child of the root exists or not. If right child of root exists, then we are going to append this on the queue. So let us do that. Similarly, we are going to check whether the left child of root exists or not, and if it exists, we are going to append it onto the queue. And in this way, we will be able to perform our level order traversal. Once we have done the level order traversal, let us reverse the list. So in order to reverse the list, what we are going to do is we are going to set I equals to 0 and j equals to length of answer minus 1. And then we are going to iterate on I and j while I is less than j. And then let us swap the elements. So temp equals to answer I equals to answer j, and answer j equals to temp. And then let us increase our counters, and towards end we are going to return answer. So that's the code, folks. Now let us compile and run it. So there is no issue with our code. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.